Hi everyone! Today we're going to learn how to conduct non-parametric tests on JMP, and I'll briefly talk about how you would write this. So remember, we use non-parametric tests when we cannot resolve our assumptions. Now, oftentimes our non-parametric tests are not going to be as powerful. What we're dealing with here is ranked data instead of it being processed as this real rich data. If we look at like this city miles per gallon, it's going to put all of this like in order, like by rank, and then it's going to be just working with those rank numbers. So for example, if the lowest city miles per gallon is, I don't know, a 13, and then the second one is a 19, there's a lot of space between those. And so, but it's just dealing with rank 1 and rank 2 rather than the true differences between that continuous data. So it's not going to be quite as accurate. Now, this is not very hard. It's just different words that we're using. So it's just the vocabulary, and these people who have invented these statistical tests, they have their names on there. So let's say we want to do a version of the one sample t-test. So what we will do, I'm going to walk you through that. We're going to compare city miles per gallon to just a preset value of 20. So this would be the average city miles per gallon for cars. And I found that in the literature or online. So I go to Analyze. I go to Distribution. I put in city miles per gallon. What I'm doing is exactly what I would have done for a one sample t-test. Here I'm going to test the mean. I'm going to enter 20 just like I would do for a one sample t-test, but I'm going to click on Wilcoxon signed rank. And so what it will do is it will show me what the one sample t-test was, but because I had to do the non-parametric, this is what I'm looking at right here. And so when I report this, I'm going to put Z equals this number. I do not need to worry about a degrees of freedom for Wilcoxon signed rank tests. So you don't see a letter Z here anywhere, but you're going to write Z equals this number, comma, and then you're going to report most likely the two-tailed. This is the p-value. Now listen, if this is consistent with the one sample, you can just simply report the one sample test as long as you explain that you did conduct a non-parametric, but because it was consistent, you are reporting the you had to do the non-parametric, but you're going to report the parametric. Okay, so that is what you do for a one sample t-test. Pause it. Okay, so now we're going to move on and we're going to look at, well, what do we do for an independent t-test? And so we're going to compare two groups. Now here, I want to compare front wheel drive to rear view drive and look at city miles per gallon. Now I've got to sort my data so that I can exclude both. So what I'm going to do, I'm going to go to, I think, tables. I'm going to put sort, and I want to sort that drive column. Okay, and now it's going to put it in a new data set, and I want to exclude all of these both sets. Okay, so I'm going to now just exclude this from my analysis. I'm going to go to here, hide and exclude. That's what I want to do. All right, so now I'm just dealing with front wheel and rear wheel drive. All right, so I go to Analyze. I'm going to do fit Y by X, and I'm going to just put my groups here, and my dependent variable here is the Y. And I would typically use t-test, right, for my independent t-test, but the substitute is the non-parametric Wilcoxon test. So I click on that, and what you will see here this is what you will look at. You will report this z-score right here, and this is the p-value. This does not necessarily involve degrees of freedom, so you don't have to worry about it. But this is what you would report right here. And you would write z equals negative 3.82. Is this statistically significant? Yes. And what you could do is to see if this is consistent with the regular old independent t-test, and it is also statistically significant. So really, all you really have to do is say, we did a non-parametric, we conducted a non-parametric, but because it was consistent with the independent t-test, we're reporting the independent t-test. All right, so there's that. Now, in the literature, I want you to know that sometimes when you see this reported, is a Mann-Whitney U test is often reported that U equals something, the letter U equals, or the letter C equals. But because JMP reports this as a Z value, that is what you will actually report. Right? So now what we're going to do a Wilcoxon z-test for the partner with a dependent t-test. So what we're going to do, we are going to look at, oh, I've got a phone call, just a second. Let me just pause this. This is why I usually make these at night. Here we go. All right, now we're going to go back to the data set I had before that includes the both drive, all right? And I'm going to compare how highway miles per gallon compare to city miles per gallon. I'm going to use the dependent t-test because I'm going to look at this where I'm comparing the same kind of the same car, and these are related means. All right, so these are related means together. It's kind of like pre-post test, but it's more like highway miles and city miles. So I'm going to go to analyze matched pairs, and I'm going to throw those in as my paired responses. And this is what my dependent t-test shows. It is statistically significant, but to see if that is consistent, I'll do the Wilcoxon here, and this is what I would report. Now, this is interesting, so listen. When you write this up, even though that says an S, you need to write Z equals this number, comma, and then this is the p-value. Even though I know this is an S, you need to write Z. And it's usually reported as Z in the literature as well. So again, because this is consistent with the dependent t-test, you can just simply report the dependent t-test. All right, now we're going to do one more. We're going to do an ANOVA. Now imagine you try to do an ANOVA. You're going to look at 3 different groups, but 3 or more different groups, but you can't solve your non-parametrics. So what we're going to do, we're going to look at types of drive, but we're going to use all 3 groups. So I'm going to go to Analyze, Fit Y by X. I would do this like a regular old vanilla normal ANOVA. All right, there's my groups. And then I'm going to look at city miles per gallon. And I would typically choose ANOVA, right? But I'm going to look at my non-parametric Wilcoxon. Now listen, it's called Wilcoxon here, but really what we're looking at is the Kruskal-Wallis, and the Kruskal-Wallis is the test that you use for ANOVA. That is the non-parametric that goes with ANOVA. So, but it's called Wilcoxon / Kruskal-Wallis here. And this is going to show you right here is what you're looking at. You're going to report the chi-square value. Write it as the Greek symbol chi-square. And then you would write chi-square and go and put degrees of freedom here equals 15.91. And then this is the p-value. Again, if it's consistent with your analysis of variance, then you would just report the F value for the ANOVA. Now, in other literature that you read, the Kruskal-Wallis test is usually reported as an H, just so you know if you see an H in the literature, capital H. But for what you need to do, because you are stating in your dissertation that you use JMP software, you will report the chi-square. So that is how you'd conduct non-parametric tests for tests of comparison. When you do correlation, I'll just show you in that video that you would use Spearman-Rowe, and that's a very easy, quick button to push. All right, so thank you very much. You guys have a great day.